Good afternoon, guys. Right now, what you're seeing in front of you is so let's bring down these windows. It's a Webassign layout. You guys are first year students, so you probably haven't seen this before, but pretty much what you're gonna do is you're going to go to the shell. You have a whole bunch of modules, but the Webassign module is right here before week 1. You can click on here and then it will load the credentials. Remember that the credentials have been posted already, but just so you can see them, you need this key, right? So far I have posted 4, there's actually 5 assignments ready. I have to post chapter 5, but they are not too long, but you need some time. Now, remember the deal that if you, and it's in the syllabus, all right? If you have 80% or above on the assignment, you will get 100% of completion or for your grade. I will still try to do most of the problems to study for the quizzes and tests, but let's take a look at chapter 1. And remember, guys, after chapter 1, we're doing chapter 3. And then we go back to chapter 2 because I want to make sure we review the math and vectors and the trigonometry on chapter 3 first. So for chapter 1, I mean, you have seen already the video, right? But you have a lot of sig figs. Be careful because sometimes what you're going to notice is that you guys have different numbers. So even though I expect that you guys can collaborate with each other, the problems may be different. All right, the numbers, not the problems, the numbers. So let's take a look at this. This is just to calculate the area, but obviously this is a significant figures problem. You have 3 sig figs here, 3 sig figs here. So what I want you guys to do is you have to multiply, and then, is that right? Okay, so you have to round the number that you see there to 3 significant figures. Right now, the calculator is giving me 4. So 7,548, to have 3 sig figs, you will round it to 7,550. Now, you're probably thinking, what about the 0? Well, remember that in this case, the 0 is not significant. If it was 705, for example, here the 0 is significant because it's in between 2 numbers. Or if I had something like here, now you have 5 sig figs. So you have to be very careful with the rules. I know that it can be confusing, but it's practice. So that's why I'm doing a tutorial as well, right? So you guys know. So that the answer will be that when I round it. It makes sense, right? Units. I want to go over this problem. Again, it's asking you with an area, but as you can see, now they're giving you a number with uncertainties. And you guys are going to do that in the lab. They give you the length and the width. So to find the area, well, obviously, just like we did in problem 1, right? You first are going to do this. But the uncertainty on the area, you guys are going to do what we know as relative uncertainties, which I am really hoping you go and do in depth in the lab. But that's the idea. The relative uncertainty on the area is equal to the summation of the relative uncertainties of the length and the width. And, well, the uncertainty on the area will be the area times this. So let's do this first. We have 2 sig figs here and 3 here. So the rule of the multiplication says that we have to do 2 sig figs for the final answer. So again, 209.72 has 5 sig figs. To round it to 2 sig figs, it will be 210. All right. The relative uncertainty will be 0.4 divided by 21.4. That's for the length. Plus 0.1 divided by 9.8. So the uncertainty on the area will be 210, the value of the area, multiply, right, times all this. All right, so I'm going to do this step by step because we have to be careful with how we do the calculation. 1 sig fig, 3 sig figs. Well, I need to have only 1 sig fig. So, all right, that's a good, let's do it again. 0.0189. I need to round it to 1 sig figs because you have the 8 after the 1. This will become 0.02. And then I'm going to do 0.1 over 9.8. Ah, that's easy, 0.0. If I multiply 1 sig fig, right, with 2 sig figs, so I need to have only 1 sig fig. So the area I hope this helps, guys. All right, that will be the answer for this part. Then you have to do the volume, is the same procedure. I show you how to do a problem like this in class. You have to do trigonometry. If you have questions, let me know. But it's basically, oh, here. They give you the circumference. Remember the circumference is equal to 2 times pi times r. And remember that pi is irrational. So it has infinite decimals. So infinite sig figs. Be careful with that. So obviously, this has 3 sig figs. Let me show you actually how to find the area, the radius. So you need a radius to find the height. Look, it doesn't matter what you use for pi. Actually, I have it here. So I get 3.21. Okay. So this has 3 sig figs divided by 2. So actually, we need to do that. Yeah, you need to have only 1 sig fig at the end, right? Because 2 is only, so 3. The radius is 3. You know, at the end of the day, that's fine. Okay, 3 meters. And then 3 times the tangent of 54 will give me the height. Okay, I want to go over this problem because you're going to see it as well. This is a calculus problem. Although they give you the steps, I'm pretty sure you guys need to review some of the algebra as well. We're going to be doing this later in the course, but that's called variable density. In real life, the density of an object is not constant. It depends on the composition of the material. So sometimes it can be a linear variation. For x0, the density is 3. For x 13 centimeters is 19.5 grams per centimeter cube. So the y-intercept will be 3, meaning that for x0, b is 3. So here I will write 3. 3.0, right? How do I find c? C is the slope. Remember that this is your y values, this will be your x values, obviously. So be careful with the sig fix as well. 19.5 minus 3.00, you need to have only one decimal place. That's fine, very good. Divided by 13. 3 sig fix, 3 sig fix, 1.27. So that will be my value of C. And then you have to integrate this with respect to the volume to find the mass. So you integrate this by doing, it doesn't matter here at the end, you can just put this like that. Actually, how do you integrate a linear function? First of all, the 7.00 comes out of the integral because it's a number. And then the integration of 3 plus 1.27x dx is the antiderivative, right? $13.0, free sig fix. So at the end of the day, guys, because you are going from 0, 0 doesn't matter because we'll give you 0 that. Free sig fix and free sig fix, not bad. Be careful with the sig fix, guys. I gave you 80% of the problem there. The mass will be in grams. You have to divide by 1,000 to get into kilograms, all right? Be careful with that. So I hope that this helps, guys. I will be opening office hours. Practice this, all right? Remember, you can always go into this to read the problem, to get some hints. The next one will be chapter 3, which will be the assignment on vectors. I will be going over this assignment. There are unit vectors in here, components, addition of vectors graphically, and in component and unit form, unit vector form. All right, so make sure that you are watching the lectures, asking questions, and obviously send emails or questions as you go through the course. All right. I will see you guys later in the next video.